Well, welcome everyone to the Decarbonizing Construction Sacred Heart Parish case study webinar brought to you by the Carbon Leadership Forum of Alberta and ENBIX. My name is Alicia Kudo, and I'm the program specialist for ENBIX at Alberta Eco Trust Foundation. As we carry out our work across Alberta, we commit to respecting and upholding the values and traditions of the Indigenous communities who have lived and continue to live here. Alberta Eco Trust Foundation operates all across Alberta, so we recognize the traditional territories of many diverse Indigenous peoples. This includes Treaty 7, Treaty 6, and Treaty 8 nations, the Blackfoot Confederacy comprising of the Siksika, Kainai, and County First Nation, the Cree, Dene, Nakota Sioux, Saulteaux, and the Métis Nation of Alberta. These lands have been stewarded by Indigenous peoples for millennia who have maintained a deep and enduring connection to this land and its resources. We honor their histories, languages, and cultures and recognize the significant contributions they have made and continue to make in this region. As we carry out our work across Alberta, we commit to respecting and upholding the values and traditions of the Indigenous communities who have lived and continue to live here. For those who may not know us, Alberta Eco Trust Foundation is a charity that leads and supports environmental and climate action projects in Alberta. We were founded over 30 years ago by environmental not-for-profit in the oil and gas industry. We've partnered with often unlikely groups to help mobilize environmental action, and our programs include grants. As an LC3 founding member, we have also an endowment that allows impact investing. We help run programs where there is a gap in the industry, such as our HUP program, ENBIX, and Retrofit Accelerator, and we're well known for our strategic engagement. Alberta Eco Trust has two programs that support the building industry: ENBIX, which stands for Emissions Neutral Buildings Information Exchange, and Alberta Eco Trust Retrofit Accelerator. ENBIX is a collaborative initiative of Alberta Eco Trust that brings the building industry together to share knowledge, build capacity, and support building and renovation practices across Alberta. The goal of ENBIX is to reduce emissions from new and existing buildings across Alberta. We do this by hosting events, sharing resources, and developing and strengthening the skills of people and organizations through training, peer-to-peer learning, and communities of practice. Our Retrofit Accelerator is a free coaching program designed to guide building owners and managers through sustainable building upgrades known as deep retrofits. These take a whole building approach to standard upgrades to reduce emissions, energy consumption, and operating costs. So just a quick check-in with those joining us on this webinar today. Kate will post a Zoom poll here in just a moment, and we're just going to find out who's in the room with us today. All right, nice cross section between Calgary and Edmonton, and some others joining us from elsewhere in Alberta, and even someone from outside of Alberta. That's really great to see. Okay, great. Okay. Sorry, Kate, I'll get you to, I don't know if it's allowing me to remove the poll or not. We'll just move on. In the interest of time, we'll just move forward. So the Carbon Leadership Forum accelerates the transformation of the building sector to radically reduce the greenhouse emissions attributed to materials, also known as embodied carbon, used in buildings and infrastructure. They research, educate, and foster cross-collaboration to bring embodied carbon of buildings and infrastructure down to zero. The CLF Alberta Regional Hub advances program goals that align with the Carbon Leadership Forum's mission to reduce embodied carbon in the built environment. By advocating for sustainable practices and innovations, they contribute to the reduction of embodied carbon emissions and support CLF's mission, creating a community focused on making a meaningful impact. So our co-host today is Christina McKillick, and she's the co-chair of CLF Alberta Hub and a project manager at Footprint. Christina has dedicated her career to championing sustainable initiatives in the building industry, providing advice to project teams, mentorship to colleagues, and volunteering with professional bodies such as the Carbon Leadership Forum, and many other organizations she's been involved with over the years. And she's managed sustainable certifications and strategies for a diverse range of clients in Alberta, BC, and Ontario, from landmark healthcare projects to commercial and education settings and interior fit-outs. Christina is especially passionate about reducing embodied carbon and leverages her extensive knowledge in this area to help clients identify and reduce impacts. So with that, I will hand the microphone over to Christina. Thanks.
Excellent. Thank you so much for the introduction, Alicia. I'm very happy to have everybody here today with looking at CLF Alberta and talking about decarbonization. So really happy that Audrina Lim will be here with us today. She's a great friend of CLF Alberta, and she'll be talking a little bit about the Sacred Heart Parish project. First, want to do a bit of a quick introduction for Audrina. Audrina is an Australian-Canadian architect with 20 years of professional experience. Her work is interested in ethical, sustainable development, which has empowered her to shift careers into sustainability realm with Chandos Construction, and she is working as the Director of Carbon Transition with Chandos right now. Audrina's role enables her to support Chandos to deliver low carbon buildings, attain energy targets, and reduce their GHG emissions in operations. And her experience as an architect and management professional has been able to provide great insight into those areas, especially with collaboration with industry partners to build that healthy and resilient low carbon construction sector. I know that Chandos was talking about the hypothesis of do less, so I'm really excited to hear about that. So Audrina, I'd love to hear more about the Sacred Heart Parish project, and I'm sure everybody here is as well, to talk about the envelope replacement and upgrades. So I'll hand it over to you, and I understand as well that you have some guests here today. So I'll hand it over to you so you can get started.
Thank you. And thanks everyone for giving up an hour of your time to come and join us and support some really, really great initiatives and an environment of sharing. And in that respect, I think Jonathan and Tavia from Chandos Construction, they're joining us. So feel free to pop a question in the Q&A or the chat. Ask them any questions. That they've been at the forefront of this, and they've been really, really developing up this excellent culture of how we can think differently and how we can execute work as efficiently as possible, leading to a lot of these emission reductions. So I'd just like to give these guys a big hand. Thank you. And also, I think our sustainability coordinator, Manny, is also popping into the seminar, and we'll say good day. I'm going to share my screen, so bear with me. So as we go through this, feel free to, pop a question in, and Christina will probably just field the questions, and feel free to interrupt and jump in, because I want this to be super interactive, and I want people to feel like, you can learn something that's really pertinent to your sector, because I think there's a lot of people from different fields here today, and it's important for us to understand what role we play in decarbonization. So can everyone see the screen? Yeah, okay, so I'll get started. So a quick outline for today's presentation. I just wanted to introduce the case for reducing emissions, the urgency to act, and our own decarbonisation journey as a corporation. Then I'll jump into the case study, understanding what the project is about, the Sacred Heart Parish. And then we're going to go through the background, the value engineering, the cost savings that attracted, and just give you kind of like a business's usual sort of practice, and then how we actually started looking at it in terms of a sustainability and emissions lens. So the third part of this presentation will go through emissions reductions, how we measured the changes, how we utilized the idea of these innovations to actually create a baseline for doing things differently. And so we'll go through material, activity, and schedule reductions, and some of the complexities of how these things are measured. And then we can have like a bit of an open discussion if you're happy with that. And we've got a ton more stories that we can share from the field. And one thing I wanted to kind of highlight is that our team has also recently delivered another project with some really amazing efficiencies using the same sort of support systems and culture on site to enable them to also meet really great objectives. So I'll get right into it. Okay. So the case for reducing emissions. So very interestingly, in recent times, we've actually seen a movement in our emissions profile. So from 2022 data, buildings represented about 13% and just for the operational carbon. However, when you add in how that electricity or gas is produced, the materials of the building, the transportation of materials to site, all of this, it actually jumps to closer to 30% of our emissions profile, which is significant considering we have a heavy emitting oil and gas sector in our Canadian local profile. But what I do want to focus on is the impacts that we have in the construction industry from the manufacturers, the procurement teams, and the general contractors, all our sub-trades, the design teams, how this whole entire picture looks and what part we have to play to try and find ways to reduce. So what you can see, I wanted to share some good news. I just looked for some more recent data. So in 2022 to 2023, we actually saw some real impacts. So with energy efficiency, we can see a decrease in 10 megatons of CO2 emissions or equivalent emissions, and also through the decarbonization process. All the actions that everybody's taking is actually having an impact. I know activity's gone up, but we can see that there's been some challenges with our housing crisis, COVID, and a lot more transportation because we've had to diversify our supply chains. And as we navigate the upcoming tariff situation and the changing global and political profiles, we're going to see this hopefully stay on track. We are very much committed to doing our decarbonization. And in Canada, this is actually written into our statutory requirements. So until that changes, we are all in. And even if it does change, I'm sure we are all in. So a little bit about the why. As we all know, the globe has been warming, and I wanted to kind of show some actual data that supports this. So these are Canadian, these are the frequency of the world of the natural disasters, and this is Canadian specific data. And this goes from 1980 all the way through to, this was 2023 when the data was published. And you can see the frequency of natural disasters increased significantly across the world. Now, these are in like low-lying areas and areas that have been impacted by floods, ocean, sea level rising, fires. We've seen a lot of that in the news, and especially in Australia, where I was raised and grew up and started my initial career. They've had some significant fires as well. And in Canada, we see significant steps towards, trying to understand what that looks like. We've had atmospheric rivers. They've claimed lives. We've had fires which have claimed lives, livelihoods, and houses. We also understand that this has further impact beyond that. And you can see in Canada, like it hasn't always been consistent, but it is starting to ramp up. And we are starting to see that more and more in the warmer summers that we have. And I know that there's been a lot of like, but what about it still snows and it's so cold, we get these polar vortex. I just wanted to dispel that myth. What actually happens when we have a consistent climate, one that is predictable and has been established over eons, is that we have a consistent jet stream. And that actually gives us reliable and predictable climate. And what happens is when that climate changes and we see some heat events, we start to see a movement in the jet stream and it starts to undulate. And that's why we get snowstorms in Georgia. We get Texas had their whole grid froze and fell apart. We start to see destabilizations of the climate as we know it. So for us, we need to go back to consistent environments. We need to try and reduce our emissions so that we can keep at below the 1.5, but I know we're already getting pretty dangerously close to exceeding that. So action is urgent, and we need to start really, really trying to push the needle and make more changes. A little bit about our organization and our decarbonization journey. I just wanted to show you guys a couple of awesome studies here. You can take a screenshot and dive into it later if you want to. But I just wanted to go through why we're doing this. We are B Corp certified, and it's part of our mandate to actually reduce our emissions. We get audited on that too. And then with our GHG inventory, what it represents, how we measure, and what that dictates in terms of our actions on site. I want us to quickly touch on our market for change and just basically wrap that up in our journey to decarbonization. So with our B Corp status, we are actually doing pretty amazing. We recently scored 158 with the B Corp, and on average, companies who achieve this assessment currently sit at 50. So for us, it measures our ethics, governance, workers, community, environment, and our customers. So for us, it gives us a general health profile of our organization, and we continue to strive for that. And one thing I'm really, really proud of is that, you know, it elevates our standards. It ensures that we pay above living wage, and ensures we look after every action on site that has impact, and we are accountable for it too. So to me, it's like our North Star, our guiding light, and we continue to push forward because of it. Our GHG inventory. Now, this is not easy. We measure to the greenhouse gas protocol, and we have to take into account our entire organization, all our sites, our offices, our yards and equipment, and our everything that has our name on that invoice. So it actually covers quite a lot. So our office and sites, for our fleet vehicles, natural gas, heating sources, anything that's kind of listed here, basically. That's scope 1 emissions. So that's fuel. That drives most of our current attainable scope right now that we can try and reduce. The second emission would be scope 2, which is electricity or energy accounts. Could be thermal heat, predominantly electricity. So we have that in our offices, and we also have that in our sites. And the third one is things that are really hard to measure. So they kind of aggregate it, and most of the time it's factored in, and we kind of use financial data to support that. The one thing we haven't really been able to quantify, just because of the sheer scale of this, is our building materials, including all the concrete, steel, insulation, mass timber, everything that we purchase. We are working on that, and that's something that we're going to hopefully get included in the near future. And I just wanted to show you, we've been measuring since 2020, and it's not a perfect science. We are getting better at it. And so we've actually set our baseline year at 2022, where we could account for 98th percentile of our revenue in terms of the financial data that we've reviewed and allocated emissions towards. So for us, that sets our baseline year and towards our reduction targets for 2040 for our operational carbon. And it's not easy, because Manny, who's on our team, helps me do these inventories. And between us, we go through about 500 summarized lines of data, 30,000 lines of data processing, and that's just on scope 1 and 2. And we also look at about 200 to 300 sites that have been registered on our revenue reports. So this is not an easy thing, and this is something that we have to do annually. So just with the complexity of that, I wanted to demonstrate that this isn't an easy task, but it's doable, because there's 2 people on our team who does this, and we record everything that comes across our sites that's held under our account. And this is how we measure and how we learn. We also dive into our data. We do analytics where we look at, like, where is the highest use and where is the highest energy density, and what does that look like in terms of our emissions profile. So across our 7 districts, we take deeper dives into it, and we start to strategize how we reduce from that point on, because we want to have the biggest impact, and we want to understand that it can be replicable, and that we want to understand also regionality. In terms of action in our industry, there is so much happening. We know that there's new new structures of reporting requirements coming down from investments, so it prevents greenwashing. We know that there's an update in building codes, including our National Energy Code, that helps us move the operational carbon of buildings forward. Right now, it won't be until 2030 where they start to introduce embodied carbon in materials, and that's really going to start affecting our procurement. So for all the manufacturers out there, bear this in mind, that it is coming. Vancouver has already launched that into their regulations. Toronto, all their owned buildings also look for embodied carbon. We have financial incentives currently being provided through government and other funding sources. And for us as a general contractor, we look at our procurement, our strategy, and our construction collaboration to be able to find ways to reduce. And that's what we are going to dive into. Just a quick little note. I pulled this forward as well. This is the projected outcome here in this darker green line of where we can get to in terms of reductions if we continue with the planned measures, our reference case. Now, considering we just scrapped our carbon tax, we got to understand the consumer carbon tax. We got to understand what that does for signaling to our market. And we need to still continue everybody to advocate for this continuance of impact because we are making a difference. I just wanted to highlight that because if we don't take further action, it's going to be a very different looking scale. Okay, moving on. So this is our team. They did an amazing job on this project, and I'll go through a little bit more. But again, feel free to pop your questions in the chat and let me know if there's anything. So I can't really see the screen, Christina. So if you need anything, let me know. Just jump in.
Thank you.
Okay. So the Sacred Heart Parish is in the community of Strathmore, just a little bit outside of Calgary, but it is quite regional in Alberta. It's kind of almost central Alberta for those who aren't familiar with Alberta's geography or is not sure where Strathmore is. It's just outside of Calgary. What, half an hour, guys? Is it roughly half an hour drive? Yeah, northeast.
Yeah, it was like 40 minutes, I'd say.
40 minutes. And there is a little bit of infrastructure, but not as significant as you would find in an urban center. So everything has to be planned very carefully. And so a lot of this was interesting because they had an existing parish that was used at a school for 18 years and they outgrew it and they needed to update it. So this building in the community became available and it was once an IGA supermarket. You can see it in the top image there. And the bottom left image is what it became. So if we want to talk about saving carbon, let's talk about adaptive reuse. It was phenomenal that the design team could come up with this amazing concept and that our team could actually execute it in a way that was super efficient. It has an existing wood frame and it needed to have new foundations, a steel structure and wood structure as well. And it had a new tower with a elevated slope roof, a second level and a canopy. So all these minor additions, they actually had to look at reinforcing the foundations. Were there any complexities you guys found on that site before you started? But
I think yeah, so I think, sorry, I'll just introduce myself like from the previous slide. I'm Johnny, the assistant super. And yeah, so as Audrina was saying, we had this existing drab building and it was very complex in the way it was kind of framed inside. So we had the challenge of incorporating the new design into this existing, and the design was left intentionally vague so that we had an opportunity to kind of maximize how much we reused and how much we had to take out. So that was the initial complexity, I would say, Audrina. It's just the intricacies of how it was built originally and how we were going to move that into the new design. But I can chat more on that later as we go.
Awesome. So the next one is to talk about the do less or use less. When we talk about trying to avoid carbon and the biggest impacts, I got this little graphic here from Lloyd Alter, who has this really, really great blog called Carbon Upfront. And there's a link there if anyone's interested. But it's about using less material. Now, it's not always okay to just do nothing, right? We have a growing population. We have a growing community. They need more infrastructure. And we're seeing that all over the globe. So build nothing is not necessarily the answer, but adaptive reuse can absolutely be a great solution. Then we go to something like build less. How do we still have a viable construction economy if we're building less? And I think it's about building smarter, which is the next step. Then we want to look at building efficiently and minimizing the waste. Now, all of this, if you look at this, goes into use less stuff. Then we go into the low carbon materials. Then at last, if we cannot avoid these, then we offset to get to net zero carbon. Now, this is very consistent. I'm sure you've seen a lot of these pyramids go around. But what I wanted to highlight was from this project, we couldn't not do it. We couldn't do like a reduced scope of this. So what we had to do was relook at value engineering and look at like a different way of delivering this so that we still maintain time, quality, and cost. So there was a very tight schedule on this project that still had to be met. And I believe that the discussion at procurement of Chandos onto this project was that we could try and innovate the schedule. And that was a huge driver. Sustainability was never an initial mandate on this project. And it was always something that we kept as part of, you know, the way we do things at Chandos. But the biggest driver here was cost and schedule. And I believe that if you look at the end product, I don't think they lost any quality either. There's no sacrifice required if you do things differently. What I thought was really amazing about this team was that they created a collaborative environment, allowed people to voice their, you know, ideas, and created new ideas from that to execute. Do you guys have any comments you want to kind of bring forward about that? Just some thoughts, or should we just keep pressing?
Yeah, I'll introduce myself to Tabia, the project coordinator on the project. Just on what Audrina was saying, I think the collaboration portion went beyond the trades and like the actual construction part. It was like having the client in, and even the end users and the churchgoers, like they were all part of the conversation to kind of build in what the client would want, what the end users would want, and what's feasible on our end as well. So I think that really helped, and that was kind of our main focus of the collaboration portion of this project.
Awesome. Thanks, Tavia. So really, I just wanted to highlight the focus of the value engineering was in the foundations. So like, as Jonathan mentioned earlier, we had to preserve the existing frame. So that kind of renovation work is always going to be tricky, especially existing buildings. You have to go through and make sure that everything's being accounted for before you start digging. So initially the foundations here, they targeted the foundations because there was an opportunity to reduce the work. So from having an open pit for a deep foundation, they actually moved towards a screw pile solution and a shallower foundation result. So from this, everything had an existing slab. They wanted to revise this, so the engineers actually participated with the sub-trades and Chandos and the owner, started looking at all the potential impacts around this, and the outcomes became minimizing the invasive demolition, reduced cost of new foundation, including the materials and the labor, reducing the waste. You know, if you touch less, you don't have as much to haul off site, especially with a regional location, and an increased site efficiency. I'm going to dive into that a little bit more. So the original areas that were as designed, you could see what that turned the site into. Now, with a reduced schedule, that was going to be tough because safety is a concern and you have to navigate these open cut pits. Obviously, it took a lot of real estate when you had to stockpile your soils, and I guess this was the first foray. Any thoughts, guys? Did you want to kind of jump into this and maybe point out some of the challenges on that? Are you good? Oh, yeah. Go ahead.
Johnny, I'll let you talk on that. Is he lagging? He's probably lagging. Yeah, it was just the real estate, like you said, like it was. Oh, there he is.
So when I joined the project, I came. Can you hear me now? Yeah, I came in, and when I came, it pretty much looked like this. Can you get some audio difficulties? It says my, I think.
Oh no. Okay, that's all right. I can jump on. So basically there was an existing, you can see the new underground, so it had to be done. And from this, they had to rethink the strategy. John, are you back? No. Okay,
Yeah.
maybe.
Can you hear me now?
No, I think it's quite laggy. I'm so sorry.
Let me try sign out and sign back in.
Okay, we'll press on in the interest of time. We can come back to this. So you can see there was going to be some issues, and it wasn't going to be viable to meet a very tight schedule. So the alternative was to look at what was actually going to be planned. So if we were to do business as usual, this much slab would have had to be required to achieve this new addition on the southwest corner. And the original concrete footings would have had to, be dug out and redone. So you can see what was going to be required. The results, the main tower and canopy foundation, we reduced the cutting of that whole existing slab. We reduced the concrete removal from that whole existing slab, reduced the excavation, reduced site restrictions. So they would have had to shut down a portion to create a safe environment. They have to do slope backs. You would have had a lot of additional storage of the excavated material, as you saw in the earlier image. And what they ended up doing was going from having to do all of this work to just touching these points with the new design with the screw piles. So you can see the significant amount of scale of reduction of work. And there are additional benefits to that as well, less disruptive, less noise to the rural environment. So every little bit of noise you can hear from miles away because it's a prairie. And there was also a lot more emissions reduced from having to have an excavator digging around there as well. So in the mezzanine and stairwell environment, which you can see in the top right is on the north side, instead of having to remove this amount of slab and do the deep foundations, as you saw earlier, the result was very, very minor. So they ended up doing reduce the cutting of that entire slab, reduce the deep excavation, reduce the site restrictions again, because that one backed onto a laneway and had a power pole there as well that we would have had to deal with, which was not cheap. So that was all avoided. And it's not always easy to measure what you didn't do. So we'll get into that later. But we avoided having to shore up the power pole, shoring up the existing foundation wall, and excavating that whole back alley. So that's a significant cost savings that was almost going to be unintended. And we managed to avoid that by doing this alternative solution. In the nave and sanctuary, there was going to be a pop-up roof, as you can see here. This is extensive. So you can see how much was saved in this environment by going to the alternative solution. Very similar results, except for where the blue area is was where that original image you saw had to be excavated. So we got some really great accurate results out of this one. And in addition to that, you can see the physical difference on the site going from what you saw on the top to having just minor holes covered up, preserving that existing slab and making a much safer environment. This allowed for a lot of reduced material, including concrete, rebar, all the associated. The potential heating and hoarding, because this was getting close to the fall. And they actually were able to fast track this because of the reduced amount of scope. They reduced the backfill of the material as well that would have been required, and a lot of the concrete curing times, which allowed schedule to improve. So because of the schedule getting reduced, and I'll ask Jonathan and Tavia a few questions around this as well, they managed to actually save 2 months, which allowed them to beat that deep winter freeze. It was -40 that hit a couple of weeks after, which saved quite a lot on the heating costs. And it allowed them to deliver a lot earlier. I think it saved about $250,000 overall for the project in what we had measured against. So Jonathan, did you want to quickly give some insight into like how this was attained?
Yeah, I've turned my camera off. Maybe that was causing some issues. Can you hear me now?
Yeah, perfect. Yeah.
Okay, excellent. Yeah, so as Audrina was mentioning, the original plan for these foundations was quite vast. So it actually included 9 feet foundations. So Chandos kind of challenged the design there a little bit, and we proposed a solution that we were kind of comfortable with, that we knew would work based on industry standards and the National Building Code. And then that really opened the conversation with the designer and started to build that collaboration and trust that went both ways. I think they kind of understood pretty soon into the project that, you know, we were about finishing on schedule and building a quality product and getting those parishioners into the space on the budget and on schedule as we promised. And just a quick note on that, in the initial meeting with the client, when we told them the schedule, they actually laughed at us because they thought it was not achievable. And then fast forward to a year later when we were on the promised date, and we were all very proud that they kind of mentioned that in their opening service at the church, that on May 31st, as promised, we moved in, and that was a great achievement all around. So back to the schedule. So yeah, with this proposed solution of doing the screw piles, like Audrina mentioned, we were able to tighten everything up, get to a position and stage ourselves for the winter effort where we could be inside with minimal critical heating, so that we could keep going through the deepest, darkest winter, which is kind of exactly what we did there. We can go, I'll let you carry on, Audrina, and then we can just
Sure, we can jump back into that later. Yeah, for sure. Okay, so I'm going to blitz through a little bit because we're getting a bit short on time. But in the cost savings, we saved $250,000 in the foundation alone. And that doesn't even include all of the additional overhead savings that we didn't have to go additional to, right? So this is significant. And this also does not include our heating and hoarding savings because they were going to be contractually separate costs. So there was a lot more that was coming that we actually managed to avoid. But when we try and measure avoided things, we try and look at like, what is it that's tangible for us to measure? And I'll get into that a little bit more. There's some other wins. They were able to tie into the building utilities to reduce the overhead costs of fuels on site. There was a lot more like clean sites and less safety issues. We had much better constructability. So because of a cleaner floor area, they were able to work overhead and enclose the roof quicker. And that was a self-performed scope. And the team adapted really well to that and were able to then create a very much warmer environment, also providing more efficiency for heating when it actually came down to those freeze conditions. And again, the team dynamic, the focus on the pre-construction planning, measuring twice, cut once, that is the motto of this amazing team. And they've been continually delivering that on other projects as well. Some more images from the finished product. Very good. Looks beautiful. Okay, I'm going to dive into the measuring avoided emissions. So how do you measure something that didn't happen? You got to create the opportunity to ask the questions and collaborate. Create a business as usual baseline. So what that means is like, what would it be if I was just to do this the usual way? If I just did standard practice, blah, 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 cost it out, get your schedule, and look at the activities that you're going to have to do, how much material you're going to have to require. Then you can start to challenge yourself to think differently. So then another way to consider measurement is to set out what is tangible to measure. Because we want to make sure that we're not overestimating, we're going to ensure that we have some measurability. So we want to be conservative in outlining what we can identify, and I'll show you as we go through this, and that we can support it with data. So that allows you to then set a baseline and measure different conditions to the same data set. And that way you have really consistent differentials that you can identify and dive into your analytics. Then you can evaluate. So you set a beginning and end date, be specific with the activity or the activities that you're going to study. And we're going to dive into it. So material reductions. What we did was we did a takeoff of the materials. So I looked at like the total cubic meters on the before and the after through concrete pour logs. We measured the types of materials that was actually required. And then we also remembered to add the emissions required for the steel core piling, right? So in terms of materials itself, we saved by not having to replace some of that existing slab, we saved 53 cubic meters. And then by diving into an environmental product declaration for industry average, we actually applied the GWP savings, which is global warming potential. So this is the amount of embodied carbon, upfront carbon, and it added up to, if you do a multiplier of 53 cubes of concrete, it ended up at 19.1. And then we just went through and looked at all the items that we didn't have to purchase, and we actually saved quite a lot. So from there, in just doing that swap, we were able to save 107 metric tons of carbon emissions. And what that, I always like to give an equivalent to, it's the same as growing 10 years of tree seedlings, almost 1,800 tree seedlings with 10 years. That's how much carbon you would have had to replace it with, right? So the tools that I utilized, I made a simple spreadsheet. You could see anyone can do this. If you have access to One-Click LCA, EC3, or TallyCat, you can also do this too. But you can compare your baseline to your redesign or to your alternative, and you can start to quantify the units of measure, make sure they align with your EPD, outline the quantity of how much material, and the CO2e, which I use metric tons of CO2e. And so when I factor that in and you do your multiplier from your baseline to your redesign, you get to see your avoided emissions. So this is a really simple exercise I like to run. And you can actually see from the cradle to gate emissions, so your GWP, just up until that point, we were able to save 107 metric tons. So just in materials alone, we can have huge gains. In our activity reductions, this is even harder to measure. Now, for me, I wanted to make sure it was tangible. So I couldn't measure everything. I just measured some. In our activity reductions, the one thing that I could tangibly measure was the hauling of the concrete waste we would have had to take to the recycling facility. Now, I did a quick map on Google Maps on where the closest concrete aggregate recycling facility was to the site, and I could get that the mileage between there. I looked at the total, well, we do a lot of tracking of waste haul, and we know that it's about 10,000 kilos, so 10 metric tons per haul. And due to fuel efficiency, would be fairly close to that. They wouldn't move without a full truck. So we would assume that we can then look at a calculation. So the Green Freight Handbook is a fantastic resource for North America to utilize. And there's a picture of it here. You can just Google it and download the document if you're looking at doing this calculation. And it guides you through how to do the calculation. So you look at the distance your shipment will travel, the weight of your shipment, because it does have an impact on efficiency. And so for us, that would have been 10,000 kilos or 10 tons. And the emissions factor. So I went through the Green Freight Handbook, has an emissions factor of all the trucks that they utilize to haul. And we just did a simple calculation for the distance, 22.3 miles. There would have been about 20 hauls of this based on the volume and weight of the concrete by the heavy vehicle emissions factor, which would have been 2 kilos of CO2e per mile. So I had to, because it's American, I had to do the conversions to metric, and then we were able to uncover that was 8.92 metric tons of avoided emissions. And then in the additional concrete that would have had to be delivered to site, we could also measure it from our concrete supplier to the site and look at how much we would have saved as well. And in the same fashion, we saved an additional 3 metric tons. So here's a quick snapshot of how I found the heavy bulk emissions factor. And you could have that as grams per mile. So then you have to do your conversion calculations and apply that emissions factor, and you'll be able to do your calculation. So again, I'd used a very simple spreadsheet and looked at my emissions factors and was able to ascertain that was 12 metric tons of emissions saved just by avoiding those 2 activities. Now, I couldn't avoid all the other activities, but I could identify these ones specifically. Schedule reductions. Now, how on earth do you account for total schedule reduction of what activities you didn't do? Again, I had to quantify. So I looked at the heating and hoarding itself. Because we were able to shorten the schedule, we were able to save on the heating and hoarding prior to that deep freeze that we had in the end of 2023. It went to -40 for those who may not remember, but it went to an absurd amount of cold, and we actually had to have that the shutdown on a lot of our power sources so that we could conserve energy. Now, on this one, we looked at the 2 months of savings on the construction schedule, and it enabled the priority to be pushed forward for the construction work. And we didn't have to do this heating and hoarding. So for me to be conservative, I measured one of the heaters we would have had to use. So 400,000 BTU propane heater. And I found the fuel consumption rate from the manufacturer's catalog. It was 16.5 liters per hour. I looked at how long it would have had to run. And if we had extended this by 1 week, I calculated the number of hours, which would have been like 24 hours a day for 1,008 hours for that week. And I wanted to look at like what that meant in terms of our emission savings. So I had to add that over here. So we wouldn't have had it full time, but, oh, sorry, my bad. I'm going back. We avoided 5 weeks of heating because we didn't have to do that heating and hoarding because we moved it forward so quickly. So instead of running it 6 weeks, we only ran it 1 week, for example, on one equipment piece. So by doing that calculation where we had the 16.5 liters hour to 168 hours of running it, if you're only going to run it by 1 week, we could actually find that savings. So this gets a bit complicated as well. When we wanted to measure what were the actual emission savings, we have to understand what CO2e means. And CO2e also has the equivalents for CH4, which is methane, and N2O, which is nitrous oxide. So using these conversion factors, which are here, emissions factors, the equivalent of a CO2e for methane is 29.8 times the same impact as it would have if it was carbon dioxide. So by pulling all this math together, it's pretty simple actually, we were able to ascertain that we saved 26 metric tons of avoiding running 6 weeks of heating. So we were able to have the impact of 440 tree seedlings grown for 10 years just by moving the schedule forward and not having to use one of the heaters for 6 weeks and just using it for 1 week instead. I know that was a bit complicated, but what do we do with all this information? There's so much data here. How do I digest this? So by creating a scale of impact, by understanding the potential impacts each of these things have and educating ourselves and getting a literacy around it, we're able to use this to start predicting what we can save in our next project. So then we can start to measure again, improve our literacy, our data, our accuracy, measure again, set our emissions budget, measure again. And we can keep going until we really get an idea of what activities have what impact. And we can plan ahead in a much better way with much more financial accuracy and acumen. In the same light, we can do that with emissions in the future. So we're going to scale the action. We're starting to look at scaling this action across more sites. We're starting to signal to the industry through talks like this that we can actually do this together. And imagine if everybody found that one action that they have impact on and can measure that, and we can start to say, here are some steps we can take. And this can create our decarbonization strategy. And that's what we're doing. We're creating a playbook on how to do low emissions construction and not just business as usual. So yeah, I think this is good time. We've got 10 minutes left, and I just wanted to see if anyone has questions or you want to share some of your own experiences and encounters. So I'm going to end my slideshow from there and hand it back to Christina. Stop my share. Okay.
Excellent. And yeah, if anybody has any questions, feel free to put them into the chat or the question and answer, or just feel free to unmute yourself. But while people are thinking of questions, I actually had one. When companies are maybe looking into doing this type of investigation, what kind of, I guess, knowledge do you think that they should have? Like EPD awareness? What type of tools should they be looking into as well?
Absolutely. So first and foremost, if you're trying to do your own reductions, understand what materials you're going to be using. Like if you're in construction or if you're in design, understand how much material and what's actually available on the market. If you can reduce the design and make it more efficient to use less, that's the biggest impact. And we were involved in a white paper that's about to be released on exactly that. So keep an eye out for it from Clean Energy Canada. And the second, like, talk to the CLF, talk to ENBIX, talk to anyone who has these resources and are amazingly well connected. And they can always put you in touch with teams like ours who can help guide you, who can also share our information. Like, we are so happy to see people wanting to take this on and wanting to up their game and wanting to have impact that's positive for the environment and for the climate, and also market signal. The more of us who do this, the more accessible, the better knowledge, and the more consistent our measurement will be. And I think that's like join the green drinks in Calgary if you're around. I know I haven't been able to get out to those yet with my schedule, but I think there's so many ways to network and learn from each other and not be afraid to share lessons learned. Or like, even if I was like, I tried this and I failed abysmally, the fact that you tried is already a huge step forward. And it's just about measurement and learning from your experiences and, you know, having a discussion with your peers. The EPDs, super easy to access. So EC3 is a really great free tool. Got to support that one because I think their funding is getting potentially jeopardized by the American government. We also want to look at, like, we have a subscription to One Click LCA, and also on all the manufacturers' websites, like I think Concrete Alberta, they publish all of the entire like baselines and also what potential different mixes can account for your GWP. And there's so many other avenues. Like, a lot of manufacturers, ask your sales rep, ask and say, if you don't have one, we'd be really interested. So you market signal them to take action. Yeah.
That's great. I end up asking a lot of manufacturers if they have EPDs so that we're able to try to get a bit more of that data instead of just working from an industry-wide perspective as well.
Yeah. And from the architects in the room or from the specifiers in the room, you know, do you guys ask your, you know, your supply chains or your contacts? Will, I saw you wanted to say something.
Hi, Audrina. How are you?
Hi. Good.
I'll just pop my screen on.
Yeah.
Audrina and I were friends from uni way back in Australia. Look, I guess the transfer of carbon and the kind of attitude towards carbon in Australia, for instance, is changing. We have a measuring system called Green Star, and now the latest version of Green Star has turned into this kind of climate positive pathway, which is really a 20% reduction in carbon from a base case building scenario. So for instance, you have a base case office building and it does certain things, and then you tweak it to do the Green Star and you drive it up. And so I guess as part of that process now, we do have to be quite mindful of our material choice, low carbon, whatever. That's the rise of cross-laminated timber and all those sorts of things. But I guess so that's kind of my take on your question. But I actually had a question, which is all the great stuff that you guys are doing over in Canada, is that starting to transfer to other jurisdictions, like, you know, for instance, my own, or into the United States or Europe or those sorts of things? Is there cross-pollination and sharing of that kind of ideas?
Absolutely, yeah. I know the European environment has a lot of action, and they're actually leading the charge. The UK, for example, uses the RICS standard of measurement, and I think how we terminologize the measure of the embodied carbon in a building is through something we call an LCA, life cycle assessment. And it takes into account, it's basically you're auditing the building materials and you're applying the base case versus a reduction case. So I think we're quite similar on that. We're seeing a lot more decarbonization action in construction through, in the US, actually. They did have some So the SEC had released a requirement that any purchasing from publicly listed companies had to be declared on their environmental impact. So that triggered everyone to have to start moving. Now, with intelligent policies and regulations, we're able to force some action to be taken. And I think we also have to incentivize. So this doesn't come cheap. We see that sometimes there's a premium, but if you have enough in the market, it actually becomes no premium. And we see in our recent research about 30% of reduction in your concrete shouldn't have a huge premium attached to that. Actually, I saw someone from Heidelberg, Cement. Are you guys still online? Maybe you wanted to talk about that. Okay, maybe not. But yeah, we see some reductions, and we see ability to actually source local. And now, as we're faced with some challenges on the tariffs from the south, from our lovely southern neighbors, we also can start looking at like, okay, transportation and local sourcing. We know we've got good clean energy in Canada, especially in our BC and Ontario markets. We've got a lot of clean nuclear, we've got a lot of clean hydro. The production of materials in those locations are not only great because it's Canadian dollar, we're also supporting local industries, but we're also having to transport less, and we actually start to build our own resiliency in that way as well. So sourcing local, building to your vernacular is super important. And I think for all the designers in the room, understanding what's available in your local market can also help you just find really good sustainable materials. Even if you don't measure, at least you know that it doesn't have to be shipped in from far, far away. Yeah, thanks for your question. I saw something here. Good to see you, Will. So I saw a question on the chat.
Yeah, we do have a question in the chat as well, but I believe we had some additional items to go over in the closing there. Alicia, are we okay to do one more question, or let's do it?
Yeah,
All right,
absolutely.
thank you. Okay, perfect. So the last question we had is, how often did the team meet to achieve the goals of reduction? It seems like there must have had to be a crossover with corporate goals and project options.
I think I'm going to hand this one to Tavia and Jonathan. Are they still online? Yeah, Tavia and John, do you guys want to answer that question? How often did you have to meet to collaborate on this?
I would say many times an hour for however many hours a day we're on site. So yeah, it was continuous. So my answer to this will be like, in construction, it's a common adage that like it's easier to knock it down and start fresh rather than work with what's existing. I think there's times when that can be true, but I think a lot of the times the challenge is more intellectual rather than physical in getting through that hardship. So on this job, we decided to give it a go, and we tackled those thousands of questions that came up with this base building. And the only way that we could do this and get to the building to a pace where we could efficiently build onto it was due to the strong collaboration with the project team, the designer, the client, the architect. So yeah, to answer the point, we would talk constantly on Teams chat, or hey, do you want to jump on a quick Teams call? And I'd have sketches ready, and it was just very fast and furious that way. And yeah, we were just very upfront with complex designs off the bat, and luckily they were willing to work with us and get through it. Lots of communication needed to pull it off.
Yeah, agree. Just to piggyback off that, I think it's easy for on a management side of thing to kind of sit in the office and not be on site as much. But I think what made this super successful is all of us being so like intertwined in what was going on in the design, the different alternates that we could figure out, and just the collaboration. We were always on site together and always communicating, so that definitely helped a lot. But yeah, definitely a lot of collaboration and time meeting up about this.
Awesome. And I also wanted to quickly throw one thing in, is this team has also gone and delivered their next project in a very similar fashion, and they've improved their efficiencies, and they're able to still meet challenges and rise to any kind of existing building condition too. So I really applaud them for that, and like, good work, guys, like, and encouraging everyone to have a voice and to speak up and to elevate everyone in their role on the project. I think that's super important. And if we can build an entire industry with that kind of collaboration and that spirit, I think we would be leaps and bounds ahead. So that'd be awesome.
Awesome. Well, as they say, the most sustainable building is one that's already built. So we love this example of adaptive reuse. And thank you so much for CLF Alberta and the team at Chandos Construction for joining us today. If you're interested in learning more about LCA and EPDs, we will be CFL Alberta's next webinar coming up in May. That will be the topic. And we'll also be hosting an in-person workshop in Edmonton on April 28th ahead of the Alberta Energy Efficiency and Innovation Summit. Our next webinar will be on April 10th. And this is part of our residential building technology series. So more than a view, considerations for window design and installation. And this one will be in partnership with Saria. So we thank you so much for joining us today. Once again, a huge thank you to CLF Alberta and the team at Chandos Construction. And we hope to see you on the next one. We've put the registration to the link to the registration for the next webinar in the chat box as well. So thank you again, and we hope to see you at the next one.
Thanks, everyone. Bye.